Hey guys, welcome back for our second section of today. So earlier we were talking about parallelograms. Now in the second section, we're going to recognize the conditions that ensure a quadrilateral is a parallelogram and then prove that a set of points form a parallelogram in the coordinate plane. So we're kind of doing some converses of the things that we did earlier today. So here's some theorems. So these are conditions for parallelograms. So 6.9 says if both pairs of opposite sides of a quadrilateral are congruent, then the figure is a parallelogram. And that's exactly the converse of something that we already talked about. Okay, 6.10 says if both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. Okay, 6.11, the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Just the converse of all these things that we've talked about. Now the 6.12 is a little bit different because it's combining two things. So it says if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So that's kind of like what we did earlier, but we're mixing the definition and being parallel and congruent. Okay, so let's put these to use. Oh, first we have a theorem. We're proving it, okay? So we're given that WX is congruent to ZY, so let me just mark that. Okay, those are congruent. And then it also says WZ is congruent to XY, so I'm going to do a double mark on those. Okay, now we have to prove that this figure is a parallelogram using this. So basically what we're doing is we're going to construct this little imaginary diagonal. And since that diagonal is going to be congruent to itself, we can easily prove that these two triangles are congruent by side, side, side. And then using some alternate interior angles converse, because all the parts are congruent, we can prove that it's a parallelogram. I don't want to spend a ton of time on that, but we can move forward. Okay, so we have to determine whether this quadrilateral is a parallelogram, yes or no. Well, I'm going to say, since the opposite sides are congruent, yes, it absolutely is. So it says each pair of opposite sides has the same measure, therefore they are congruent. Great. And it just talks about that property that we discussed just earlier. Okay, so why don't you guys pause your video really quick, take a look at that, see what you think. So it says which method would prove the quadrilateral is a parallelogram? Is it both pairs of opposite sides are parallel? I think it only shows us one. Both pairs of opposite sides are congruent. It only gives us measures for two sides, not four. Both pairs of opposite angles are congruent. It doesn't have anything with the angles. Or one pair of opposite sides, both parallel and congruent. It's got to be that, right, guys? Because both of those, that top and bottom, they're both 15. And that little triangle in there is indicating that those lines are parallel. Okay, so next example, we kind of have some real-world situations again. So this is a scissor lift. It's used for lifting heavy items. So it says in the diagram, angle A is congruent to angle C, and angle B is congruent to angle D. So I'm just going to go in and mark those in. I'm going to use some different colors. So I have A and C, and then I got B and D. Hopefully you guys can see that. Okay, it says explain why the consecutive angles will always be supplementary regardless of the height of the platform. Now let's think about that. Okay, so we got this diagram, and it's saying why are the consecutive angles? Well, what are the consecutive angles? A and D would be consecutive, B and C, D and C, then A and B. Okay, so I'm going to go to the next page. It's going to kind of talk about it. Okay, this is a long answer, but we can sum it up pretty easily. It says since both pairs of opposite angles of the quadrilateral are congruent, then it's got to be a parallelogram, right? We do a little bit of substitution in here. This is kind of confusing. Oops. Okay, let's have you guys try one, okay? So it says the diagram shows a car jack used to raise a car from the ground. Here's the car jack. In the diagram, segment AD is congruent to segment BC, and segment AB is congruent to segment DC. So again, sketch it on your paper if you'd like. Kind of think about this. The question that's being asked, which statement will be true regardless of the height of the car jack? All right, so pause your video. We can start thinking about this a little bit. Now I'm just going to go in and mark what they gave us. So AD was congruent to BC. Okay, and then it also told us AB is congruent to DC. So that's the information that they gave us. So which one of these statements will be true? Angle A is congruent to angle B. Probably shouldn't be. Angle A is congruent to angle C. Okay. Segment AB is congruent to segment BC. Maybe, sometimes, not always. And then the measure of angle A plus the measure of angle C equals 180. You know, it might, but if they were, they would have to be both equal to 90 degrees. So the answer that we're going here is B, because those are those opposite angles. They're always going to be congruent. Okay, so now a little bit of algebra. We're applying the knowledge that we know using these properties. So we have to find x and y so that the quadrilateral is a parallelogram. Okay, well, if it was a parallelogram, this 4x minus 1 would be equal to this 3 times the quantity of x plus 2. So we could do some stuff with that to find a value of x to make it a parallelogram. And then also with the other sides, this 4y minus 2 and this 3 times y plus 1, those two should be congruent as well. So let's just do a little bit of math over here. We'll do the x's on this side. So we're going to have 4x minus 1 equals 3 times the quantity of x plus 2. Okay. First step here is we're going to distribute this 3 through. Your 4x minus 1 equals 3x. 3 times 2, we get plus 6. Okay. Now we're just solving for x. So I'm going to subtract this 3x over, add the 1, so I get x equals 7. Okay, so that's my value of x. And what this is saying is if we plug x, or 7 in for x here and here, those lines are going to be congruent, which is exactly what we need in a parallelogram. Now if on this side I do my y's, so I have 3 times y plus 1 equals this side, this 4y minus 2. Okay, again, since we have those parentheses, we're going to distribute the 3 through. So I have 3y plus 3 equals 4y minus 2. Sorry for the delay on the smartboard, guys. Okay, still solving for y, so I'm going to subtract the 3y over, add the 2 over, so I get 5 is equal to y. So again, if we plug that 5 in for y, it's going to make those sides congruent, and that's what we're looking for here. All right, these next slides are just doing exactly what I just did with you. X equals 7, we got that. And y equals 5, we got that as well. So when these variables equal these numbers, we got ourselves a parallelogram. Okay, so why don't you guys pause your video right now, work out this solution. We're looking for the value of m. Okay, so if these are going to be congruent for a parallelogram, we're going to set them equal to each other, and you guys should be finding 6 for m. Okay, that one was pretty simple. Okay, so here's a little bit of a concept summary, kind of like what we did at the end of this morning's first section, right? We kind of made a list of some characteristics of a parallelogram. So, in order to prove that a quadrilateral is a parallelogram, first we could show that both pairs of opposite sides are parallel, show that both pairs of opposite sides are congruent, show that both pairs of opposite angles are congruent, show that the diagonals bisect each other, and show that a pair of opposite sides is both parallel and congruent. So if you guys were given a diagram and you had to prove that it was a parallelogram, you have all of these things to choose from, and these are the theorems that go with them and the definition. Okay. So when we're using coordinate geometry with these, we have a couple different tools that we can use. To find the length of one of these segments, we can use the distance formula. To find the slope of a line, we use the slope formula. If we needed to find the midpoint, we could use the midpoint formula. So those are some of our tools that we can use. So if you're ever kind of in a pickle and you don't know which direction to go, you're going to want to pull from that toolbox. Okay, so we have quadrilateral QRST in the figure over here, and then it gives us their vertices. It says determine whether the quadrilateral is a parallelogram. Justify your answer by using the slope formula. So there's kind of some different ways that we could approach this, right? We could find the midpoints of some stuff, construct the diagonals, we could find the slopes of all the sides. Now let's ponder that. If we found the slope of this TQ and SR, if those had the same slope, that would make them parallel, right? And then same with the TS and QR. If they have the same slope, they're going to be parallel. But we also need them to be congruent. So if those opposite sides are congruent and parallel, we know that it's a parallelogram. So I think we're going to try to use that approach. So we find the slope of QR using the 2 points that they gave us, and we find that that slope is -1/2. And that's a nice slope. Maybe you could notice that just by looking at it. So now we're going to find the slope of ST, which is also -1/2. Okay, so we have some opposite sides that are parallel. And if we find the slope of RS using those 2 points that they gave us for those, we find that the slope is +4. Now we have to find TQ, which is also +4. So we have opposite sides that are parallel. And so since that's true, we have ourselves a parallelogram here. Okay, so here's one for you guys to just kind of take a look at. So it says graph quadrilateral EFGH with vertices, then it gives you some vertices. Determine whether the quadrilateral is a parallelogram. Okay, pause your video, maybe make a couple little side notes, draw yourself the diagram. Okay, so I think that we should tackle this problem just like we did in the last problem. Find the slopes. Okay, but first I'm just going to sketch something out here. Okay, so we have quadrilateral EFGH. Now this might not be drawn to scale, but I can at least plug in the points. EFGH. Okay, and we know what our points are. So what we should be finding is that EF is parallel to HG. And if it was a parallelogram, we should also be finding that EH is parallel to FG. And when we plug in the numbers, we get some different slopes. So the answer is no, it's not a parallelogram. All right, so throwback to maybe a couple chapters ago, maybe last chapter, I can't remember. We did coordinate proofs. Some of you guys liked those, some of you didn't. So we're going to write a coordinate proof for this statement. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay? So step one, we have to create our proof. So we're going to position the quadrilateral on the coordinate plane so that AB is congruent to DC and AD is congruent to BC. Okay, so maybe on another sheet of paper we can do this together. So we have to place the vertex A at the origin because that's what we always do with the coordinate planes. It would be silly to not start at 0, 0. Okay, says let AB have a length of A units. Then B has a coordinate of A0. And on this next page, we'll kind of show you the picture of it. Maybe I'll just flip through okay. So here we are. We have A here at the vertex, and AB has a length of A. So that point becomes A0. Now up at the top, it says so that the distance from D to C is also A units, we're letting the x-coordinates of D be B, and of C be B plus A. Now I don't know if you followed that, but D can be at any x value, so we're just calling it B. Okay? And to make sure that these are congruent segments, we're just adding A to it because A is our distance from A to B. Okay? Now that we know that those two segments, these segments need to be congruent, okay, so we're just going to raise it up C. So our y value is C for both of these. Okay, now we use our figure to write a proof. So we state what was given, state what we're proving. By definition, a quadrilateral is a parallelogram if opposite sides are parallel. We showed that in our diagram. We're going to use the slope formula. So just like we did in that last example, we're finding the slope of the opposite sides. If they're equal, then they can be parallel. Oops, let me go back here. Okay, so we found the slope of AD using those points on our coordinate proof that we constructed. Okay, so when we take our point CB and our 0, 0, we get C over B. Okay, the slope of AB is 0 because that was just a horizontal line. Now BC is also C over B, that's our slope. Okay, and then the slope of CD is 0. So it's kind of looking like we're getting opposite sides that have parallel slopes. And there we have it. Since we have parallel slopes of the opposite sides, we have a parallelogram. Okay, so here's one for you guys to kind of take a look at. This one's a little easier because it gives you the diagram. Okay, so it says if a quadrilateral is a parallelogram, then one pair of opposite sides is both parallel and congruent. So which one of these is true? Why don't you guys pause the video, take a look at it, think about your thoughts. Okay, so this says AB is A units and DC is A units. The slope of AB is 0 and the slope of DC is 0. That seems true. And then it says AD is C units and BC is C units. The slope of AD is B over C, and the slope of BC is B over C. So what are you guys thinking? We're going to go with option A. Okay? So here's our assignment. It's page 418, 9 through 37. And again, you guys can skip a couple proofs for the fact that you'd have a lot of questions on them. So we'll see you tomorrow with the next section. Good luck on your homework. Let us know if you need any help on them.